Hey there, I am S and this is S Solution. If you're interested in our NT algorithm, you're preparing for interviews, and you want to get familiar with algorithm questions, or you are someone that like critical thinking and you want to be engaged in the mind. These are very engaging, mind engaging uh, algorithm questions. Please do subscribe, like, and share, and let's get into it. In the last video, we looked at StairCase and we went through it iteratively, but here we want to use recursion to actually solve the same question and see. Alright, so if we go to our board, we'll remember that we start from 0 and we have 1. At this point we have 2. This gives us 2 and 3. This gives 3 and 4. This gives 4 and we stop here. This is already 4. This gives 4 and 5 is nothing. This gives 3 and 4. Give 4 and we stop here. So for recursion, we are basically the same thing. So we are always adding 1 and 2. So here 1 and 2. We're adding 1 and 2. Here we're adding 1 and 2. But for recursion, you must know at what point you want to come out of it. So at what point do we stop here? We stop when we have reached the number of steps. For example, we have reached the number of steps. Number of steps here is 4. Number of steps here is 5, which is not valid for us. So whenever we exceed the number of steps, we know that it's invalid, so we can say it's 0. But whenever we reach our number of steps, it means it's valid. We can give it a 1. So basically what we'll be doing is at point 0, we want to add the number of steps at 1 and the number of steps here. But at 1, we keep going. So this is the number of steps here is 1 plus 0 gives me 1. The number of steps here is, okay, 4 is 1 because that is 4. 1 plus 1 gives me, so we're adding this, so it gives me 2. So we're adding this 2. So but I can't add this, I have to get this. This is 1 plus 0, this gives me 1. So this is 1. 1 plus 2, this gives me 3. 3 plus, okay, we don't know what it is. So this is 1 and 0. So 1 plus 0 gives me 1. This is 1. 1 plus 1 gives me 2. 3 plus 2 gives me 5. So basically what we're doing is we're summing up this one and the next. So that means we're summing plus 1 and plus 2 together. That will give me my count. And I keep doing that. Okay. So I like to have my recursion outside. So function, let's call it steps recurse. I think that's a good name. Steps recurse. And so what do we need here? So we want to okay, we want to continue going through this until we have reached, okay, so when you are doing recursion, you need to know where you are breaking. So we are stopping when the number of steps, when we have reached the number of steps, or when we have gone beyond the number of steps. Okay, so if, so how do we keep, okay, so we need the current step and we need to know the total okay, total steps. So if the current step is equals to our total steps, I don't know if total steps is a better name to use, but so if it's equals to total step, that is, for instance, if it's 4, it means we are returning a 1. But if it is more than 4, if it's more than the total steps, we are returning a 0. Okay, so let's have a variable here that keeps count. Let's say count. So count is equals to, so basically, if what I want to do, for example, at the beginning is going to be, I want to basically do the same thing, our current step, but for the next step, for 1 plus 1, and I want to add that to that of, okay, I think this should work. So total steps. Okay, so basic what we are doing here is, okay, we are saying that, so for example, when it's at 0, you do so step 1 and step 2. 0 plus 2, that is step 1 and step 2. You sum it up. Whatever your step 1 and step 2 gives you, that is your count. And this is return our count. Okay, so here we call it stairs recurse. We start at 0 and we are going all the way to steps. Okay, our total steps is so. Okay, we have to let's see what our answer is. Let the result is equals to. So what is the result? Okay, so result is 5, which is what we expect. So let's go for something smaller. Let's go for 3. Let's go for 3. Maybe 3 will be simpler to explain. So when we are step 3, let me copy this 1 2 3 4 5 6 7. This is 1 2 4 5 6 7 8. Okay, so I will go ahead and comment all of this because I want to focus on 3 for now. So when the number of steps is 3, we want to come here. So the diagram will be for 3. For if it were 3, it means our diagram will look something like this: 0 1 2, 2 plus 1 2, and this is 3. So this 3 will be 1, it will return 1. This will be 3 and 4. 4 is nothing. This will return 0. It's more than 3. It's more than 3, yes. And this is 1. Okay, this is 3 and this is nothing. So this is 0 and this is 1. Okay, so at the beginning it comes and say, okay, this 0, so 1 plus 2, whatever my count for 1 is and whatever my count for 2 is. But you see, it has to console, but we can't get, so this goes on whatever the count of 2. So at 1 it comes and say 1 plus, for 1 we have 1 plus 1, which is 2 and 3. So it goes here and say, okay, this plus this goes ahead and say this plus this. And because we have said here that it either stops when it is equals to the total step, for which is 3 here, or if it is greater than that. So it will stop here. So it stops here. 1 plus 1, 1 plus 0. And where we say 1 plus 2 is because we are doing this. So this is for when it is, for instance, 3, and when it is 4. So when this will be 0 and this will be 1. So the result of this becomes 1 plus 0 is what? 1. This is 1. So 1 plus 1 is 2. Okay, this is 1. 1 plus 0 is 1. So 2 plus 1 is 3. So basically that is it. So I think we are good. So let's check everything out. Okay, sorry, we have to return our result. Or I could just, okay, for simplicity's sake, let me just say return result. But I could just say, I could as well just make it as this. Maybe I think I would prefer it that way. Okay, I could just say return result and I get the same. Okay, so since we are okay now, so this works fine also, and see it's much cleaner and it's simpler now. But we have an issue now. If let's say I come here and I say 30, kaboom, it's problem. Okay, we are good. 30 seems okay. 90, okay, let's see. Okay, now it becomes problematic. At 30, if you notice, 30 was a little bit slow, but it came out. But for 90, let's see, we're going to have to wait a long time if it ever comes out. And that is a problem when you are solving recursive questions. This is something you need to be careful about. So how do we solve this now? So what we need to come back to our question and we need to we see that there is a pattern. So let's come back to our example of 4. when you reach this 3, what you notice is that for 3, the sum is what? 1, because 1 plus 0 is 1. If you come to this 3 also, the sum is also 1. If you come to this 3, the sum is also 1. So you notice that we're actually repeating this over and over and over again. So it does 3, 1 year, 1 year, 1 year. It does it 3 times. If you go to 2, if you look at 2, the sum at 2 is 2. The sum at 2 is also 2. We're repeating it even though the answers are the same for each. So for 3, the answer is always going to be 1, 1, 1. For 2, the answer is always going to be 2, 2. So why do we need to repeat it over and over again? So it means we can, what we could do is when we do the first one, for example, when we have done this one, we can store it somewhere so that when we come to 3 again, we don't calculate it. Instead of calculating, we just say, okay, have you done 3 before? It says yes. What was the answer for that 3? 1. It just puts 1 here. It doesn't go through all of this again because it has done it once. So why do it again? It just stores it and goes on. It comes here. Oh, we have this value 2. It says 1. Fine. It comes to 2. So for instance, here 2, it has already calculated 2 to be 2. So when it comes here, it just say, oh, 2 is 2. We don't need to calculate anything. So it cuts off all of this. So it cuts off all of this. All of that goes off. We are just left with, so it just gets this 2 here for us. Also, when it's doing for 3, it cuts off all of this. And we are left with this 3. So it just gets this 2, it gets this 1. It doesn't bother doing this because it has 3 already here, so it just gets the value here 1. It doesn't bother going to get all the value because it knows 2, the value of 2 is also what? 2. And then, so, and in algorithm question, dynamic programming, this is what we call memoization. It's like memorization. It's not memorization, but memoization. If I were to spell that for us here, memoization. This is how it's spelled. So memoization. So it is very simple. Memoization is very simple, and it's actually something that you've noticed that it's actually a sequential step-by-step something. So basically, so when you're doing memoization, you need an object, for example. So let's call this store. So it's an object, and this means that at the beginning the object is empty. That's what this is. Or rather, no, if this value is not given, the value it takes is what? Is empty. So if it is given a value, it uses that value. But if store is not given any value, it uses whatever is here, which is, for our example, is an empty array. Okay. So we want to say, okay, wherever we are returning our count, what we want to do is, instead of returning count, we want to store the count. So for example, we want to store our count. So for this step, for this particular current step, we want to store our count. Okay. So, and then you pass it here. Sorry, store, and this is store. Now this, but you also want to, what you have just done is you have stored the value. What you want to do with this stored value is that you want to check at every time that you want to check if that step we're about to, which is the current step, if it is inside our memo. We don't want to go over it again. That's the point of all of this. Sorry, if it's inside our store, we don't want to go over this again. So what do? We just want to get whatever that value is at that step. So we just want to go ahead and get, okay, if that value is not, if value is in store already, don't bother calculating it, just get that value back for me and go with that. That's basically what this is trying to say. So at the beginning, what it does is, okay, it gets the value of store at the beginning. So for example, here store is not given, so it initializes it. We're saying that, okay, at the beginning, if not is given here, you give the value of store to be something which is empty here. So when it is 0, it says, of course 0 is not in the store, not is in the store at the beginning. So it's not equals to steps, it's not greater than steps, and then it comes in and say count is 0. It's going to be step 1 plus step 2. It goes ahead. When it gets to step 2, it calculates it. But when it has calculated for step 2, for example, it comes in and says step 2, and the value for step 2, remember, is 2. So whenever it comes again and sees step 2, it doesn't calculate that because it will have stored it inside our store. If I were to show us what store holds now, you will see that it can't. Oh, how can I show us? Okay, I think this is what I can do. Yes. So here I'm saying that, okay, at the beginning it will solve for 0, 0 is 1. At step 3 we have 1. At step 1 we have 1. So what this basically is doing is keeping track, is keeping record. It's saying what current step are we on now. The problem is, okay, we can't see all our values. I wish. So let me do store. Okay, I think this will. Okay, now this will be so long, but basically now. Oh, okay. Let me, since we're dealing with 4, I was wondering why it was giving me all of that there. So let's just do for 4. Let me try to use that to explain. So I didn't need to put it in console. Okay, since it's less than 10 values I have. So at the beginning it goes, the first value it stores was 3. The value of 3 is 1. If you remember when we saw for 4, that was what we have. When we are doing for step 3, our answer was 1. So if you come back here, our answer is 1. So anytime it sees 3, it has stored 3 already, so it never will calculate for 3 again. So if you come here and say if that current step is in our store, if it's not there, it goes on, but if it is there, it will use that. If you just come and get the value. So we come again. When it gets to 2, the sum of 2 is 2. So it will never calculate for 2 again. When the current step is 2, it knows that the total count is 2. When we get to, for example, let me look for another one. When we get to step 1 is always going to be 3. So it will never calculate for 3 again. It knows that the value is 3. And then, of course, our step 0, which is where we start from, is going to be what? 5. So it will never calculate for all those points again. That's basically it. So let's uncomment this, and let me comment this, and let's look at our 19. Let's see, was this helpful? Okay, let's look at this. Do we have a problem here? So it seems we have a problem. Let's go over this again. So we are saying here that in our store we are keeping track of this. Okay, let me pull this out. Let's see. Okay, so let's make this 30. Let's start with 30 and see. Okay, let's go to 60. So something. So it's supposed to keep a store of this, and okay, let's look at this and let's see. Okay, so we have just 60, so it keeps going in. It is greater than it, so we are storing it here, we are using it in each of them, and that's basically the 3 steps that we need here. But something seems off. Could it be my system? It doesn't seem. I wouldn't be sure why it's doing this. Okay, everything seems fine here, except when we make it. So we're adding one, we're storing, we're adding two, we're storing. For each of them we store. Oh, the problem. We are not returning. Sorry. So we have to return that. Sorry, my bad. So basically that's it. And you see, so if we were to go 90, the value comes out in, and so you see the value is so large that if it were to go over it the normal way, it will be, imagine if I were to show us, if I was to show us this, imagine this was going up all the way to 90. Imagine how many branches it will have, how many times it needs to calculate, and it's repeating the same thing over and over and over and over again. So memoization is very useful. So what it will do for us, it keeps track of what we have gone over before, and make sure we don't go over such again. That instead of calculating, it says, oh, this has been calculated already. It takes that value and it makes use of that value. That's basically what this is. So if we come here and we see the basic steps for memoization, basically is we have a store which we initialize at the beginning. For example, here it is not given, so it is initialized at the beginning. And each time, so what I basically will do is wherever I'm returning my answer at the end, that is where I will come and put my store. That's where I will populate my store. So I am populating my store. So because anytime it comes here is when it gets a unique value, because we have already said if it already exists, it will return it here. But if it can go through all of this, it means it's not a unique value. So we have to store whatever that unique value is. That means we have reached a step that has not been crossed before. So we store that. And then it goes again. So, and it's very important that you keep that, you put that store back. So because why we are putting the store here is because we are going, this is the store. Whatever is being stored here is what it will use to check in the next one. If for example you remove the stores in this, it will not, it will initialize it again because store is not given. So but if you want it to keep continuous storage, you must pass it into these functions. And basically that's what memoization will help us do. This, if you make this 190, your answer comes out boom, because it doesn't go over anything double. It does it once, and once it does it once, it cuts it off. And this will give us a more efficient, so this is more efficient way of solving this number of steps in a staircase. I hope this was helpful. I know that we had to walk through, and I was happy that we had that challenge, so we could see how we were able to walk through this, and we saw that it was because we were not returning this, so it will basically still come into this, and I didn't change anything basically because I'm not returning my value back in from the store. So I hope this was helpful, and I hope it was insightful. uh, if you enjoyed this, please give it a thumbs up, like, and subscribe, and I hope we see you in the next video.